Okay guys, you know the drill. Go ahead and get started on your bell work. You have about 5 minutes to do this, and then you can get started or review it with me here in just a little bit. So go ahead and pause the video, take 5 minutes, try this on your own, and then we'll look at it together. Alright, so just like what we did on Friday, we're graphing the function y equals negative 3x. We'll compare it to the graph of y equals 1x. Now you did that the y equals 1x one on that worksheet that we did as part of our bell work on Friday. So if you recall, we first talk about the asymptotes. And when we have a function that looks like this a over x, our asymptotes are horizontal here is at y equals 0. Whoops. At y equals 0, and our vertical is at x equals 0, right here. So along our axes, and then I want you to plot 4 points. And because I like numbers that are easy to work with, I usually pick -2, -1, 1, and 2. But I know that if I put 2 in here, it's going to give me a fraction. So if it's okay with you guys, I'm going to go with -3, -1, 1, and 2. I'm sorry, 1 and 3. So I plug in -3 for x. -3 over -3 is positive 1. -3 over -1 is positive 3. -3 over 1, -3. And -3 over positive 3 is -1. Remember, our asymptotes, we can't be at 0, so if I'm going to plot these, there's obviously not going to be 1 here at 0. So here is -3, 1, -1, 3, and I'll try this. Oh, okay, it can't cross there, right? So it should look like this. And then when x is positive 1, y was at -3. And when it was at 3, we were at -1 here. It should look like that. Okay. When we had the graph of 1, this graph right here, this 1 over x, you should have had points at like 1, and 1, 1, and 2, 1/2. And remember, it went this way. So the difference is that negative flips it. I know that's not very good, and I kind of missed it, but if you recall, this is what it kind of looked like. Wow. Sorry, you're going to have to bear with me. I'm doing this with the mouse, so it's kind of challenging, but okay. So comparing to the graph, it's been reflected and stretched out because of this increase. It's not 1 anymore. And our asymptotes were at x equals 0, y equals 0. And our domain and range is at all real numbers as long as x does not equal 0 for domain, and all real numbers as long as y does not equal 0 for range. Now the second part down here says fill out the first row on the half sheet. You should, the substitute should pass out a little half sheet for you. It's kind of a cheat sheet when it comes to dealing with these rational functions. So the first row has you filling out where are the asymptotes on graphs that look like y equals a over x. If you remember, your horizontal asymptote is at y equals 0, and your vertical asymptote is at x equals 0. So make sure you get those filled out and don't lose them, because you might get to use them again, and we're going to add to them today. So moving on to the notes. Section 8.2, Part B. Again, graphing simple rational functions. Your central questions for today: do I recognize the function of a rational function's graph, and how do we graph those rational functions? So we're doing exactly what we did on Friday, except notice that I throw in h and k this time. We've used h and k a lot last semester, this semester. remember that when you have h, you do the opposite, and it's going to move you horizontally. So if it's a negative h, we're really going to go to the positive side, right? So we're going to move to the right. And if it's plus h, we're really going to go to the negative side. So we'll move to the left, however many units that is. And k tells us to move up or down, and we do the same thing as it says. Like if it's positive, we go up, and if it's negative, we go down. Okay, just like h and k every time else that we've done this semester. So you will graph things exactly as you did when it was y equals a over x. The only difference is that you're going to translate this h and k, and your asymptotes also will change. So before our asymptotes were at 0, now your horizontal asymptote is at the line y equals k. And your vertical asymptote is at the line x equals h. All right. If you guys need to pause at any time, you can do so, but I'm just going to keep going. All right. So first, let's graph this. And I think it's really helpful for all of us if we just graph this part first, this 1 over x, so that we remember what it looks like. So I'm going to graph that in black. Remember that the asymptotes were on the axis when it was in this a over x form. So if I'm going to go 1 over x, I had the point 1, 1, and I believe we were at 2, 1/2. And I'll try. Kind of goes like that. Remember, it doesn't come up. I just can't draw a straight line. And we were at -1, -2, 1/2, something along these lines. Yes? Okay. So that is when it's just y equals 1 over x. But now let's look at what h and k does. So this -3 tells me I'm really going to move to the right 3 units. And this tells me I'm going to move everything up 1 unit. Okay. Before I get into that, though, let's talk about where my asymptotes, my new asymptotes, are going to be. My new asymptotes are at x equals h and y equals k. So my vertical asymptote is at x equals h. H is 3. We do the opposite, always, always, always. So x equals 3. And the horizontal asymptote is at y equals k. K for us is 2. We keep the same sign on this one. So at x equals 3, 1, 2, 3, we'll try and make this dotted. We won't cross there. And at y equals 2, it won't cross here either. Okay? So step 2, we're going to translate this graph that I drew in black, right 3 and up 2. So this point, I'm going to count 1, 2, 3, up 1, 2. It should be right there. And this half, we go over 1, 2, 3, up 1, 2. I'm trying to draw this as best I can here. Remember, it won't cross the asymptote. It's going to get really, really close to it, but it's never going to cross. So there's the hyperbola. There's step 3 for you on that side. But I also need to move this one over 1, 2, 3, up 1, 2. So it's this right there. And this half one moves over 1, 2, 3, up 1, 2. And it looks like that, kind of curved. Okay, so this red graph is our final graph here. So step 3 was draw the hyperbola, which I did there in red. Right. So now domain and range is just a tiny bit different than before, but not really, because remember I told you domain is everywhere the asymptote is not. So the domain is everywhere as long as x does not equal your asymptote, and your asymptote was at 3. Okay, so on the x-axis, I could be anywhere I want as long as I'm not at 3. And on the y, my range can be anywhere as long as it's not at the asymptote of 2. All right. Pause if you need to, otherwise we're going to continue. All right. And say if you want to at this time, you could probably give yourselves a chance to try it. So you might pause the video for a few minutes. Otherwise, I'll walk through here. Notice that I put this little note over here. Start by graphing the parent function. So by that, I mean start by graphing the y equals -3 over x part of it. Then we'll translate here in just a little bit. So if you want to, you can make your little t-chart. We did just do this one for bell work, if you remember. So I'm going to use points like -3 because I know that -2 will give us a fraction, and some of us are, fractionally inclined. I'm just kidding, guys. -3 over -3 is 1. -3 over -1 is +3. -3 over +1 is -3, and -3 over +3 is -1. Remember, you can use 2 if you want to. I just know that halves are a little bit trickier to graph. So that's why I went ahead and put in -3, so I didn't have to deal with that. So fractions are not a bad thing. They're just trickier to graph. All right, so, and the original asymptotes in the graphing function is on the axis, so I'm not going to actually plot those for right now. We're plotting just the parent function right here. So at x equals -3, y was +1. -1, we were at +3. And I make real, there we go. Okay, so it looks like that. And at +1, we're down here at -3. And at +3, we are at -1. So it should be mirrored right over here on this side. It's really, really close to the asymptote, but never actually touches it. Okay. Now I'll go to these steps that I want you to talk about. I want to look at the H and K. I'm going to erase that so you can still see it. So first, start with your asymptotes. Your asymptotes are at H and K, so we need to determine where H and K is. So here, this +2 is H. I do the opposite, which means I'm actually going to move to the left 2. K tells me to move up 1. So that means my asymptotes are moving as well. Your asymptote, your vertical asymptote is at x equals h. So x equals 2, -2. We do the opposite. And your horizontal asymptote is at y equals k. Keep the same sign here, so it's at y equals 1. So -2. Try and get it all on here. And y equals 1 goes this way. So we're not going to cross, oops, the new one will not cross these blue lines here. All right, so there's our asymptotes, our new asymptotes. Step 2, translate these points. So this point from -3, 1, which is right here, it's kind of hard to see, -3, 1, we're going to translate to the left 2, 1, 2, and up 1. This point I'm going to translate left 1, 2, up 1. And now I have, ooh, there you go. This hyperbola, so there's step 3, hyperbola. This guy I move left 1, 2, up 1, 1, 2, up 1, and I draw in the hyperbola. And I don't cross the asymptote, so it should be right there. That graph in red is our final graph. Okay. When we talk about domain and range, the domain is everywhere your vertical asymptote is not, so your x values. So it's all real numbers as long as it's not -2. Because at -2, we have an asymptote, we can't be there. In case you were wondering, it's because at -2, if I plug in -2 right here for x, it gives me a 0. And remember, you can't have a 0 in the denominator. It makes it undefined. So that's why our domain is at x equals -2. And our range is everywhere as long as it's not at 1. Okay, questions about that? If you need to, you can pause. Otherwise, I'm going to go on. Yay, homework time. Okay, so hopefully you guys have a little bit of time to work on this in class today. It is page 561B, number 11 through 21 odd, so it's really not too many problems. If you need to, there should be graph paper in the room on one of the shelves. So, good luck.